When dealing with wiring in crawl spaces, especially when concrete walls have pre-drilled holes positioned below the joists, several effective solutions can be considered. These methods ensure code compliance, safety, and ease of future maintenance. Firstly, core drilling is a method where you create larger holes in the concrete wall using a core drill and insert polyvinyl chloride, or PVC, sleeves for conduit runs. This provides a protected path for wiring, allowing for easy wire pulling. Secondly, the wall cavity chase approach involves cutting out a horizontal section of the drywall and framing on the side of the concrete wall where the holes are located. Wires are then run within the cavity and it is covered back up with drywall, providing access for future maintenance. Thirdly, for suspended conduit runs, install conduit hangers from the joist above the holes. Suspend the conduit runs below the joist level, transitioning to the concrete wall through the holes. This allows for flexibility and maintenance, as wires can be added or replaced without having to access the crawl space. Fourthly, a combination of methods can be employed, like combining the core drill method for penetrating the concrete wall with the ceiling cavity chase or suspended conduit runs for the remainder of the run. Always ensure to seal the holes in the concrete wall after running wires. Expanding foam or cork are suitable for this purpose. Wire management is also crucial. Use wire loom or cable ties to organize wires and prevent tangling. Protect wires from potential damage by using conduit, wire loom, or plastic tubing. Always consult local building codes and electrical safety regulations to ensure that the approach complies. Understanding the National Electrical Code, or NEC, is essential for safe and compliant electrical work. Several articles within the NEC directly pertain to wiring methods and materials, especially when dealing with crawl spaces and concrete walls. Article 300.4 C addresses protection against physical damage. In areas where wiring is subject to physical damage, such as crawl spaces, it must be protected. This can be achieved through the use of conduit, metal-clad cable, or other approved means. When running cables or raceways through holes in framing members, Article 300.4 D specifies requirements to protect the wiring from screws or nails. Steel plates or bushing should be used where the wiring is less than 1.25 inches from the edge of the framing member. For installations in damp or wet locations like crawl spaces, Article 300.6 requires that wiring and equipment be suitable for the environment. This often means using corrosion-resistant materials and enclosures. Article 310 provides tables for allowable ampacities of insulated conductors. When running wires through insulated walls or ceilings, the ampacity may need to be adjusted based on the insulation type and ambient temperature. Article 314 covers outlet, device, and junction boxes, as well as handhole enclosures and conduit bodies. These enclosures must be of the correct type and size for the wiring being installed, and they must be securely mounted. For grounding and bonding, Article 250 is crucial. All metallic components of the electrical system, including conduit and metal boxes, must be properly grounded and bonded to ensure safety and prevent electrical shock. Section 225.30 and 225.31 discuss the number of supplies. Based on these sections, a building or structure can have multiple feeders or branch circuits, but the number of supplies might be restricted based on the specific circumstances and local codes. These sections are pertinent when determining how many circuits or feeders can be run to a detached building or structure. Article 334 covers metal-clad cable, often referred to as MC cable. MC cable can be used in both exposed and concealed work and is suitable for use in damp locations. Article 340 addresses armored cable, also known as AC cable. While AC cable is similar to MC cable, it has some restrictions on its use in damp locations. Article 352 covers rigid polyvinyl chloride, or PVC conduit. PVC conduit is suitable for use in underground and corrosive environments, but it must be supported properly. Article 358 covers electrical metallic tubing, or EMT. EMT is a thin-walled conduit that is suitable for use in dry locations and can be used for both exposed and concealed work. Article 344 covers rigid metal conduit, or RMC. RMC is a thick-walled conduit that provides excellent protection for wiring and is suitable for use in both dry and wet locations. Article 356 covers liquid-tight flexible metal conduit, or LFMC. LFMC is used in situations where flexibility is needed and is suitable for use in wet locations. For crawl spaces, it is generally recommended to use wiring methods that provide good protection against physical damage and moisture. Common choices include rigid metal conduit, electrical metallic tubing, metal-clad cable, and cables installed in conduit. Additionally, all boxes and fittings used in crawl spaces should be suitable for damp locations. When dealing with concrete walls, it's essential to consider the following factors. Determine the appropriate size and type of conduit or wiring based on the electrical load and the number of conductors required. Use the correct type of drill bit for creating holes in concrete. Carbide-tip drill bits are recommended for drilling through concrete. Install bushings or fittings at the point where wires or conduit pass through the concrete wall to protect the wiring from abrasion. Seal the openings around the wiring or conduit with caulk or expanding foam to prevent moisture from entering the crawl space. Ensure that all wiring and equipment are properly grounded in accordance with the NEC. When running wires through crawl spaces, it is important to support them properly to prevent sagging and protect them from damage. The NEC specifies requirements for supporting cables and conduits. Cables must be supported at intervals not exceeding 4.5 feet and secured to the building structure. Conduit must be supported according to the manufacturer's instructions. In crawl spaces, cables and conduits can be supported using cable ties, clamps, or straps. These supports should be attached to the floor joists or other structural members. It is also important to protect wiring from physical damage in crawl spaces. This can be achieved by running cables and conduits along the underside of floor joists or by installing protective covers over exposed wiring. When working in crawl spaces, always follow safe work practices. Wear appropriate personal protective equipment, including eye protection, gloves, and a dust mask. Use a portable work light to provide adequate illumination. Be aware of potential hazards such as insects, rodents, and moisture. When dealing with electrical wiring, always de-energize the circuit before working on it. Test the circuit to ensure that it is de-energized before proceeding. When working in damp or wet crawl spaces, use ground fault circuit interrupter, or GFCI, protection to prevent electrical shock. Adhering to these guidelines and consulting the NEC can ensure a safe and compliant electrical installation in crawl spaces with concrete walls. When planning electrical installations in crawl spaces with concrete walls and joist obstructions, understanding the specific requirements and best practices can help ensure a safe and compliant outcome. Here's a more detailed breakdown. Before commencing any electrical work, it's crucial to conduct a thorough assessment of the crawl space environment. Identify potential hazards such as moisture, pests, and any existing structural or electrical issues. Ensure adequate ventilation and lighting to facilitate safe working conditions. Consult local building codes and the NEC to understand the specific requirements for electrical installations in crawl spaces. This includes regulations related to wiring methods, grounding, and protection against physical damage. Choose appropriate wiring methods and materials suitable for the crawl space environment. Common options include rigid metal conduit, electrical metallic tubing, metal-clad cable, and non-metallic sheath cable, often referred to as Romex, installed within conduit. Select boxes and fittings designed for damp or wet locations to protect against moisture intrusion. Plan the layout of wiring runs to minimize obstructions and ensure accessibility for future maintenance. Consider the placement of junction boxes and outlets in convenient locations while adhering to clearance requirements. When drilling holes through concrete walls, use a rotary hammer drill with a carbide-tipped masonry bit. Ensure the hole is of adequate size to accommodate the selected wiring method and any necessary bushings or fittings. After drilling, inspect the hole for any sharp edges or protrusions that could damage the wiring. Install bushings or grommets to protect the wiring as it passes through the concrete wall. These provide a smooth, insulated surface that prevents abrasion and reduces the risk of electrical shorts. When running wires through the crawl space, provide adequate support to prevent sagging and protect against physical damage. Secure cables and conduits to the underside of floor joists or other structural members using cable ties, clamps, or straps. Maintain proper spacing between supports as specified by the NEC. In areas where wiring is exposed to physical damage, provide additional protection such as conduit or protective covers. This is particularly important in crawl spaces where wiring may be vulnerable to impact or abrasion. Grounding is a critical aspect of electrical safety. Ensure that all metallic components of the electrical system, including conduit, boxes, and equipment, are properly grounded in accordance with the NEC. Use grounding conductors of the appropriate size and material to establish a low impedance path to ground. Protect wiring from moisture by using waterproof or weather-resistant materials and sealing any openings or penetrations. Consider installing a vapor barrier to reduce moisture levels in the crawl space. Properly seal any holes or gaps in the concrete wall to prevent moisture from entering the crawl space. Use caulk, expanding foam, or other suitable sealant to create a waterproof barrier. Organize and manage wiring to prevent tangling and ensure easy identification. Use cable ties, labels, or color coding to keep wires neatly arranged and easily traceable. After completing the electrical installation, conduct thorough testing to verify its safety and functionality. Use a multimeter or other testing equipment to check for proper voltage continuity and insulation resistance. Inspect all connections and terminations to ensure they are secure and properly tightened. Document the electrical installation, including wiring diagrams, circuit schedules, and equipment specifications. This information will be valuable for future maintenance and troubleshooting. Keep records of any inspections or certifications obtained for the electrical work. Consider the following points for practical application. Core drilling offers a precise and clean method for creating openings in concrete walls. Use a core drill bit of the appropriate size to accommodate the selected wiring method. When cutting out sections of drywall for wall cavity chases, take care to minimize damage to surrounding surfaces. Use a drywall saw or utility knife to make clean, accurate cuts. When suspending conduit runs from joists, ensure that the hangers are securely attached to the joists and capable of supporting the weight of the conduit and wiring. Consider using vibration isolation hangers to reduce noise transmission. When combining multiple wiring methods, ensure that each method is installed in accordance with the NEC and that the transition between methods is properly executed. Regularly inspect the crawl space for signs of moisture, pests, or other issues that could affect the electrical system. Take prompt action to address any problems that are identified. By following these guidelines and best practices, one can achieve a safe, reliable, and compliant electrical installation in crawl spaces with concrete walls and joist obstructions. Always prioritize safety and consult with qualified professionals when in doubt.